chemistry, and this is our last section in chapter 13 on liquids and solids. This one is on water, especially. Water is super important. It's the most abundant liquid on Earth. It's also commonly found in all three of its phases. Liquid, it's also found as water vapor and as ice. Water is essential to Earth. It makes up 70 to 90% of the mass of a living thing. For us, it's closer to 70, but for things like jellyfish and worms, it's closer to 90% of their mass. The chemical reaction necessary for life take place in water. It's a universal solvent, and water is frequently a reactant or product in these reactions. Anytime when we get into acid-base chemistry, we're going to be talking about water again because it's the universal solvent. Water dissolves everything, pretty much. Yeah, right next we're going to talk about solutions, and we're going to be talking about aqueous solutions, which are solutions of water. We're going to be talking about acid bases and all the important things that require this background of water. Structure water. Water molecules consist of two atoms of hydrogen and one atom of oxygen, united by polar covalent bonds. The structure of these atoms is bent when we talked about hybridization and actual configurations. The angle between the two hydrogen-oxygen bonds is 105 degrees, which is close to an angle expected for an sp3 electron configuration. 105, or this 104.5, is a number you will need to know. It's a very important number. It will come up again if you ever take a chemistry class. Electronegativity of water. Oxygen is a highly electronegative atom. It likes to pull electrons close to it. Hydrogen is not electronegative. Because of this, electrons spend more time orbiting the more electronegative oxygen. This creates a partial negative charge on oxygen and a partial positive on hydrogen. We designate those with that delta plus and that delta minus. This one is more negatively charged, this one is more positively charged because these electrons here in blue are orbiting this oxygen. Hydrogen bonds. In solid and liquid form, water has bonds between water molecules. These are intramolecular forces, not intermo. This is caused as the slightly positive hydrogen, these little blue ones on here, is attracted to the slightly negative oxygen. In water, 4 to 8 molecules are H-bonded. Here you can see in this one on the right, this is the water. You can see for this one here example, there's 1, 2, 3, 4 hydrogen bonds formed to it. In solids, all of them are tightly bound. They have this really uniform pattern of bonding. Forms this hexagonal lattice work with pockets of air between molecules. These pockets of air are what allows ice to flow on water. It's less dense. How does water boil? At 0 degrees Celsius and below, the hydrogen bonds are the strongest. They hold this together very, very securely. As ice is heated, it absorbs energy. This breaks its hydrogen bonds. Once enough have been broken, the ice now becomes liquid and is allowed to be fluid. These molecules are allowed to slip past each other, slip around each other, move around. Once again, these molecules absorb energy until even more H-bonds are broken, and then once all H-bonds have been broken from a molecule, it can escape as vapor and be a gas form. So in order of most hydrogen bonds to least, it's solid, liquid, and then gaseous. Physical properties of water. At room temperature, water is a transparent, odorless, tasteless, and almost colorless liquid. Any observable taste or odor is caused by impurities such as minerals, liquids, and gases. Why does ice float? Solid ice expands in volume up to 11%. That same amount of water is taking up more space. Its rigid lattice work traps a lot of air inside of it, so this decreases its density. And things that are less dense float on the liquid. So this ice is now less dense than water, liquid water, and will float. This answer to question number 4. Your section review is page 393, questions 1 through 4, and then question 4 I just answered on the slide before this one. I hope you guys are having a marvelous Tuesday. Talk to you later.